Hello again. Okay, we've done videos that basically gave you an introduction, then we did another video describing all the three output clocks. We just did one on the slow scanning mode. This one is something that you may not use much, but it was more of a challenge to put it in there. And if you're interested in some interesting programming concepts, this is fast Fourier transforms. So it's transitioning from something we call time domain to frequency domain. It can tell you what frequencies are present in the sampled data. So, okay, so let me bring back up the... Okay, so here's our Arduino. I've connected a wire between the clock A output, which will be generating our clock, and just into the A0 input. That's the only thing I've got connected. None of this other stuff down here is connected to anything. Okay, so we've got that. So here's the program again, and I've already loaded it. I've already loaded this thing in there. The command we're going to be looking at is actually the F commands here. Okay, so let's go back and bring up my serial plotter. Again, I've got to change this to carriage return because it never seems to remember that. The 115,200, that's fine. Let me just hit that to make sure it's working. Okay, so I'm going to, clock A is off. I need that to be running, I'll pick 200 hertz. CAF200. I'll hit an extra return just so we can see that it's running. Okay, so that's 200 hertz. Oh, I've got the other one floating. Let me turn off that one just to get it out of the way. So I'm going to take a wire from the A1 line and just connect it to ground. And let me do that again. Okay. So now we've got a very clean square wave coming off of clock 0, or clock A, feeding into A0, and that's the plot we've got, running at 200 hertz. Now, the Fourier transform, if I say F1, and then hit another return, this is the frequency response of that waveform. And it has a peak. These numbers are going to be really crude, but the peak is supposed to be at 200. And this peak here actually comes in at 195. It's going to get shifted by up to about, I don't know, 4 or 5 hertz, 10 hertz, something like that. I'd have to go back and calculate that. And the magnitude of these is scaled. And the scale is kind of a little bit fuzzy. The max V over here will give you an arbitrary value. It's the fact that you've got it on here at all is really pretty, is pretty good. So this is the F1 command. It's actually only taking the first half of the waveform that you see. Let me put in F0 here. Let me go back. Hit another return. Okay, so here's the F0. And it's only taking the first half of this waveform. I'm out of memory. As I said, in this design we're really, really packed on the memory. So it's taking the first 256 samples, which are 8-bit data, and it does the Fourier transforms on those, converts it to frequency, and then outputs the frequency response. Now we also get the phase information. Let me go back to F1. And we also get, as I said, phase information. The phase information isn't typically quite as useful, but I can put it in there, so I put it in there. So if you put in F2 and hit return, you can see on mine, and I assume that it'll be on most of them, the blue trace is the same as we had before, the frequency, and the red one is the Fourier, or the phase information for each of those frequencies. So it's just something you can do, but it gets a little bit messy. Let me go back to F1 and get rid of the phase. Now, this is 200 hertz. Let me say CAF, and we'll double the frequency. We're up to 400. And it says it's 390, so I'm off by 10 hertz already. Let me go up a little higher. CAF, let's go 600. And you can see that these things kind of have really odd spikes here and there. There's when you get into the classes and you understand the Fourier transform stuff, we are going to actually have the frequencies wrap around. A square wave has, if you look it up, it's like all the odd harmonics of the fundamental frequency, and some sort of magnitude stuff in there too. And so what you would expect is the square wave of whatever frequency we're feeding in. So we're feeding in 600, and this says 586 at this point. And so let's go up a little farther. CAF, let's go for 1300. So we could just play this game all the way, and it says that it's 1289. That's not bad. CAF, 1700. Things that go off the top edge wrap around, or actually bounce and come back the other way, those spikes. So you start getting some really odd effects in here. Let's go up to 3000. CAF 3000. Oh, that one comes out really clean compared to the other ones. Now, well, let's see. Let's go on up. CAF 4000. And that one looks pretty good. Now, the spikes that are down below it are probably wrapping around, coming because of the fact that we've got harmonics and all sorts of stuff. So it's kind of hard to say. It says it's 3,986 hertz. Okay, and it also, when you input the frequencies for the clock, remember you can say CAF. If I wanted 3.56 K hertz, I can put that in, and it will understand that just fine. So it's, as I said, your usefulness will be limited, but it doesn't cost anything to put it in there, and so we have spectral analysis.